Hello, this is Thomas from tooll.io. I just want to give you a quick update of what is new with version 1.9.9. Of course, you can always go to the tooll.io wiki and there check the versions tab, and then you see a write-down of what actually changed. But to quickly go through the changes here in the visual style might be a little bit helpful for one or two people. So the first thing that changed is that we now added support to copy and paste keyframes for animations. So to quickly show you how this works, I will create a tools. One more thing, you see that in the quick create window we now dimmed a couple of operators which are internal operators of projects which you probably are not interested in. So if you are working inside a project, then of course we will not dim them, but otherwise we only show the lib and example operators by default. So I will create a tools and I will create a camera. And now if I move away and set some keyframes for this camera, move this like so and like so, and make them smooth, then I can now select these keyframes, and if I right click I get two new options here. One is copy keyframes and one is insert keyframes. If I copy these keyframes, then I have an animation segment with the length between the first and the last selected keyframes. So in this example it's roughly maybe like 12 seconds or something. And now if I move the time somewhere and right click insert keyframes, then the selected keyframes will be inserted and all the keyframes, the original keyframes after the current time, will be pushed to the right for this 12 seconds. You can also create a new camera operator, and now if I insert the keyframes here, if we find the parameter groups with the right name, we will insert the keyframes right away. You can also create another camera and maybe only take a single parameter, like here the position, and now insert this. So we will only insert this one animated parameter, which also might be helpful once in a while. Okay, that's that. So next thing is a couple of small teeny weeny updates. So one thing is that if you do a bit of editing, that you can now increase the font size in the code editor. So you can click here and use Control plus and minus to adjust that, which comes in handy once in a while. Then we added a couple of new operators that might be useful. So let's quickly run through them. So the first one is that we added support for FFT analysis of sound. So this is one of the first community contributions, which makes me super happy. So there's this FFT example here, and if I go in there, then you will see that this is actually comes from Michael. And so if I silence toggle mute audio here, now basically if I create some noise, then we see that we use the microphone in and then do some FFT analysis and then maybe extract the volume or a certain frequency. So the example, FFT example, if you look at that, you will probably realize quickly how this works. We also have now a cylinder operator, which is super nice because I need this all the time. So it's also a community how do you say this? A community contribution, which makes me super happy. Then I have been working on a small little particle system, which I needed for production. It's not final yet, especially the sorting doesn't work as it's supposed to be, but you can still do quite a bit of stuff with that. So there's if I go to example, there's a faster particles examples here. So if I create that, and go in there, and maybe I will adjust the view layout here and zoom out. Then we have a couple of examples I'm testing this system with. So if I select this one and move out, then we see some particles getting up, or this one, it's a locomotive like driving around and emitting some, maybe I will just maybe use a viewport where you can see a bit more. So this emits some letters here. This is some, I don't know what this is, some abstract stuff. I played a bit with displacement of background images, and I think I tried quite a bit with abstract stuff here. So yeah, and you can also this one explores a little bit how you can use random vectors, and from the random vectors extract the motion vector by using different times and then using this to emit the particles into a certain direction. So to illustrate you how this particle system works, let's basically start from scratch. So we basically use faster particles, and then since this has a lot of parameters, I will change my view layout again here. So it's probably one of the most complicated operators we have so far. So right now, if I try this, I will get a warning: render faster particles, missing particle texture. So we have to create a texture here. So let's just use a blob. And then if you remember from one of the earlier videos, we will use the viewports, the selection view, aspect ratios and resolutions to generate images on the fly. So they will always be rendered by default with the incoming requested resolution. So for the particles, this is not what we want, but we want a square resolution. So we will add set resolution here, and then we will pipe this into the faster particles, and now we have a little particle system here. Then the important thing you have to understand about this faster particles is that it's not a simulation. Every particle will be computed on the fly. This might be a little bit weird, but it has the advantage is it's super easy to tweak, and then you can also move time forward and backward, and it will always work out. There's one difference though, that so maybe if I increase a little bit of turbulence, and you see that I can move this around. I can also move this around back and forth in time. And there's this one parameters effect. Right now all particles. So if I move this, all particles will be recomputed. But I can also set this to only affect emitted particles. So if I move this around, then the already emitted particles, they will basically stay there. And basically, if I now move the midpoint around, then we see how particles will be emitted at this current emit position. And so I could basically bind the emit center to a certain position, and this is how this locomotive example worked. So now quickly go through the parameters. So of course we have a transform gizmo here, and if you remember, the transform gizmo is always generated on the fly if an operator comes with a center or position or translate x, y, z. So this is how we know that we want to render something there. So we'll go back to emit all particles all the time. Then we have a particle count. So since this is all done on a GPU, the particle count can go up maybe like 100,000 particles or something. It's a bit expensive, so we do a lot of stuff there. So it's not really the thing that you can do with like millions and millions of particles, and eventually the fill rate will be also the problem if you have lots of overlapping particles. But well, I guess like 100,000 or something should be okay. Then the lifetime right now is 0, because this means that the lifetime is automatically calculated by the particle count and the emit rate. So if I want to override that, I can do this, but most of the time actually I want this to be automatically calculated. Then we have the emit rate, of course. I can increase this, and we already talked about the center, and we can of course reset this if this actually only makes sense if we are in this parameters affect only the emitted particles. I can emit from different emit shapes. So right now we see this little box there. We can increase the emitter size. So we see now the particles are emitted from this box. I can of course change the size here and move it around. And a nice little thing is that you can limit the position within this emitter shape or this emitter box. So if we set this to, let's say 2, then we have 2 positions where particles will be emitted, and if you move closely we see that they're actually moving around there. This can be nice if you want to, I don't know, maybe create these abstract ribbon forms here. So if you create this, then you can create something like a, let's say, I don't know, like weird forest or something. And if you adjust the size of the emitter box, then we will actually try to distribute them evenly. So something like this. And then you can scatter these positions, of course. So move them around, scatter them for the 3 axes. And with the box emitter, this actually doesn't really make that much sense, but it's really nice if you use the sphere emitter. So let's again reset the position, the emitter size, and now we get this weird little tentacle thing. If you increase the size, then you see how like these emitters come from the center of the box. And if we would animate the turbulence, then you get something like maybe like electric flashes or something, I don't know. And then of course we have something like a ring emitter. So then we already talked about scattering. So basically looks like this scatter only works for box, which we should fix eventually. Then we have the emit velocity, which should be obvious. Right now the default emit velocity is up. And for the emit direction we have 2 emit angles, alpha and beta. Let me remove this and reset all these things here. So maybe this. So the one is this angle, and the other one is like the angle around that. And for all the values where we have 2, or the parameters with 2 values, the second one is the random distribution. So I could basically spread this apart with this. Remove this. Of course we can adjust the size, and the second one again is the random size. So you can adjust this as well. You can adjust the stretch, which is sometimes useful, sometimes not. Then you can shrink the particle over time. So either from the start or from the end, which also can be sometimes useful. You can change the orientation of the particle. So right now this is billboard, which basically leaves this in a straight arrow, but you can make this random. If you stretch a particle, you will actually see that this makes a difference. You can also change it to motion, which basically uses the motion vector to basically rotate that. And you can also use the mid direction, which right now doesn't really make sense, but if you, for instance, would spread this, then you see how this would affect the outcome. You can always also use the stretch by motion if you use the orientation motion, and this sometimes looks nice if so right now this is a bit too much here, and maybe if we decrease the size a bit, then now you see how they are aligned and aligned by the motion. And if we would add a little bit of gravity, let's say to the bottom, the faster they get, the longer the altitude gets, the longer the stretch factor gets. Then, yeah, so we talked about the gravity, so this can be used to move this thing, well, into one or the other direction. So it can also be used for simulating wind. Then we have the turbulence here, which is a little bit more complicated. So if you ungroup this parameter group, then we see that we have the amount of the turbulence. Then we have the turbulence time, which can be used to animate it a bit. We also have the turbulence scale, which basically is the size of the distribution field. So if we increase this quite a bit, then we see maybe we also like add a little bit of more particles, so to get a longer shape. Maybe we decrease the emit speed. So maybe center, lifetime particle count, emit size, emit from where was the emit velocity? So if we basically increase this, we get this long thing. And if I now decrease the scale of the turbulence field, we see how this gets more and more noisy. If I increase the scale, then it gets less noisy. It really depends on what you want to achieve. And then we also have a turbulence variation, which basically adjusts the variations between the different particles. So if you don't want to move them in a homogeneous field, but more maybe like randomly independent from each other, then use this parameter. Then we have texture cells, which basically allows you to either change different variations. So this is basically like the texture atlas, the rows and columns, and the rows basically are different variations. No, the rows are like the blur kernel, and so maybe we go through this one example, which makes this a bit clearer. Where was this? So here we see that we have a couple of letters here, and if we look how this works is that we have a text, linear, and we generate bitmaps there. So we basically have a column with four rows, and in the faster particles we set the texture cells to 1, 4. If we would have something like a dust particle texture, so dust particles, or maybe we make a load image. So we have a dust particle texture here. Then this is an image atlas of 8 variations, and I think like 16 blur kernel stages, and then we could use this So right now this looks completely weird, but if we set this to blend mode at, maybe lock it there, and then if you go back to a particle texture and set this to 16 blur stages and 8 variations, then basically we see how we get like different variations of these particles. So right now they have motion stretch here, but yeah, you get a point. So if you increase that, we have a couple of different particles, and now we can also use the focus property here to basically increase the blur kernel depending on the blur stages in the atlas, the texture atlas. Then of course you can you can change the end and the exit colors here. You can fade the particles that come too close, and you can also adjust like this is actually nice. You can adjust the variations for colors. So if you unwrap that, so you can increase the hue, how colorful they are, or you can increase the, maybe let's say all these should be red. So now if we decrease this a bit, so we can go through different shades of red, or we can go through different degrees of saturations, or we can go through different degrees of brightness, or through different degrees of opacity, which right now is ignored because of the additive blend mode. So actually this is all there is, and with this you can do all kinds of stuff. So all the examples within the faster particles examples are made with this particle system, and it needs some getting used to, but then it's super fast to get under control. So this was that. And yeah, did I mention that we have now a cylinder? We can create a cylinder. And not the deprecated, of course, but a new one here with yeah, so basically you can build all kinds of like forms with that. And well, then the final thing I have for you is that we can now import FBX scenes. So this was a super big issue, that right now the FBX importer was a bit messy and a bit hard to get under control, and now what we can do actually is import a scene. I have a test scene here, FBX reference scene FBX, and now it takes a while. So what we get here is a block that is a representation of this FBX scene. So it's like some weird scene with like all kinds of like transform tests and so on. But you see how we get a rollout of the tree, how this is basically built up. Like this comes from Maya, but we also did an extensive test with 3D Studio Max. So this should actually work and maybe fix a couple of the problems we had earlier. So, well, this is all I have for now. Some new things are coming up within the next couple of versions, and so you might have noticed that we increased the SharpDX version. This is, well, to prepare some of the stuff that's upcoming. And since we also have an Oculus node to test and play around with, there might be happening something on that front. So, as always, we are super curious to get your feedback. If you find any problems, then let us know. And yeah, see you then. Bye.